Hello. At the end of this video you will be able to walk and sprint, to crouch and jump, but also to climb around, and to pick up stuff with the friction of your hands. Everything calculated by Unity's physics engine. So let's get started. First of all, I won't cover how to set up a Unity VR project in this video. If you have never worked with action-based controllers or don't know how to set up a Unity VR project, I urge you to take a look at the first link in the description. If you are done doing this, you can follow the rest of this video seamlessly. First of all, add a stationary and action-based XR rig to the scene. Set its dimension to 0 on every axis and set the tracking origin mode to floor. Now, under the camera, you want to select tracking type, rotation only. Shove the camera outside the XR rig. And under the XR rig, you want to add a component called Input Action Manager, where you are going to shove the XRI default input actions in. Last but not least, you can disable all the line renderers of the controllers. First of all, add an empty game object which you'll call HexaBody. Set its position to 0 on every dimension. Now create a sphere under the HexaBody, which you call Monoball. And set its scale to 0.3 on every dimension. Next off, you want to create another sphere, which you call Fender. Set its scale to 0.35 on every dimension. And its position on the y-axis to 0.175. The lowest point of the fender should be in the center of the monoball. Now create a capsule, which you call chest. Set its scale to 0.2, 0.3 and 0.2. Its position should be the same as the fender's position. Next off, you want to create another sphere, which you call head. Set its scale to 0.3 on every dimension again. And set its position on the y-axis to 0.675 and on the z-axis to 0.12. Now create another sphere, which you want to call right hand. Set its scale to 0.1 on every dimension and make its position the same as the head's position. Now you can duplicate the right hand with Ctrl D and name it left hand. Now you want to select every component of the HexaBody and add a rigid body to each of them. Furthermore, you want to set interpolate to interpolation for every component. Set the monoball's mass to 5 and the fender's mass also to 5. Under constraints, freeze the rotation of the fender on every dimension. The chest will have a mass of 10 and the rotation is also frozen on every dimension. For the head, we will apply a mass of 5 and constrain it on every dimension again. The hands will have a mass of 2. Now we want to create 3 new layers. So under layers, add layer, create a body layer, a head layer, and a hands layer. Now apply the body layer to the monoball, the fender, and the chest. Apply the head layer to the head. And of course, apply the hand layer to the hands. If you have done all this, go under Edit, Project Settings, and under the Physics tab you want to set the maximum angular speed to 100. This is because we're going to move around by rotating the monoball. For a bit collision between the head and hands, and for a bit collision between body parts. Perfect. Select the fender and create a configurable joint. Shove the monoball inside the configurable joint and set its anchor to -0.5. Now you want to restrict motion on every axis. Now create another configurable joint and shove the chest inside of it. Set the anchor to 0. Lock X motion and limit Y motion. You want to set the linear limit to 1.05. Don't worry, I will go into that later. And lock Z motion. You want to lock angular X and angular Z motion to, and set angular Y motion to 3. Now under Y position, you want to set the position spring to 5000 and the position damper to 50. Now you want to select the head and create a configurable joint under it. Shove the chest inside of it and set the anchor to 0. The X, Y and Z motion should be set to locked, as well as the angular X and angular Z motion. The angular Y motion should be set to free. After doing this, create another configurable joint and shove the right hand inside of it. Set the anchor to 0 and leave every motion type on free. For position spring, choose a value of 3000 and apply that to every type of drive. And for position damper, choose a value of 50 and do the same thing. Repeat that process also for the angular drives. After doing this, create another configurable joint. And do the exact same thing, just with the left hand. Last but not least, I'll create a physics material, which I'll call high friction. Set its dynamic friction and its static friction to 10 and friction to combine to maximum. Now shove the high friction material inside of the monoball. Next off, select the friction material and apply to the right and the left hand. And that's it for the body setup. The next episode will show you how to write the code for it, so subscribe to my channel so you won't miss it. Stay tuned.